welcome to 4.4 example, and the question that we're really going to be focusing on in this section is, are the following equations equivalent? So if I look at this equation, I look at this equation, I can say, oh, they represent the same line, or they represent two different lines. If they represent the same line, then they're equivalent. All right, and there's a bunch of different ways we can do that. We could look at a graph. So we could graph both these by hand or with a calculator. We could look at what the graphs look like. We could look at the table of values and find out what happens if I put in 1 for x, what happens to y. If I plug in 1 for x, and what happens to y if I put in 2 or 3 or 5 or 10 or a whole bunch of different numbers. So we can try things like that, or we can do something a little bit different, which might come in handy sometimes. So sometimes graphing it will be great. Sometimes looking at the table will be fine. Sometimes doing it the next method will also be really helpful. So what we're going to do is we're going to come back to this, and you are going to answer this question at the end of this video. So what we're going to do is we're going to do this example A. Use a distributive property to write y equals 3 plus 2 parentheses x plus 4 without parentheses. All right. So what we are going to do first is we're going to look at this box. I'm going to represent this multiplication as an area representation. So what I'm going to do is I'm going to say this is going to be 2, and this side would be x plus 4. All right. So what I want to do is I want to be able to multiply this 2 times this x and the 2 times the 4. That way I can find the area of these two rectangles. So the area of this rectangle is going to be 2 times x, and the area of this one is going to be 2 times 4. So that means I can rewrite this equation. I can rewrite it as y equals 3 plus, instead of 2 and the parentheses, I can write it as 2 times x plus 2 times 4. All right. So now let's see if I can simplify anything. Well, I know that y equals, I know that 3 is going to stay where it is. I know that the 2x, I can't do anything more with 2x because it's just 2 times x, but 2 times 4 is 8. All right, so can I move anything around? Well, I know that the 8 and the 3 are like terms, so I can combine them. Now, I know a lot of people, what they might do is like they might say, oh, I want to undo this adding 8, so I'm going to subtract 8 and subtract 8. But if I subtract 8 from this side here, if I do minus 8 and minus 8, really what I've done is I've subtracted 16 from this right side of the equation, and that's not what I should do. So don't subtract 8. Let's in fact just get rid of it all. All right. I want to be able to combine my like terms here of the 3 and the 8 and get 11 plus 2x. So we use the distributive property to make this equation without parentheses. So it would be y equals 11 plus 2x. And if you notice, this is slope-intercept form. All right, so that is slope-intercept form. And this equation was originally in point-slope. So we went from point-slope to slope-intercept. So now I can check to see these two lines, even though they look different, these two equations, even though they look different, represent the same line. So really, we've used the distributive property. All right, so let's talk about the distributive property. The distributive property can be generalized like this. The distributive property, for any real values of a, b, and c, this equation is true. And here's the equation. We start off with a times b plus c in parentheses. Right, so if we just have some number multiplied by two numbers that are added together, so we'd say the product of a sum, right, because sum means it adding and then multiply, is going to be the same as a times b plus a times c. All right, so that means really when I say you can distribute, a lot of you probably already know that, a times b and a times c. All right, so there you go. There's the distributive property. There's your example. Let's go back and look at this problem right now. Are these two equations equivalent? Meaning, do they represent the same line? What I would suggest you do is use the distributive property on this one to see if it looks the same as this one. Are they the same? What you do is take the 5 to both of those, right? So we could say y equals 7 plus, and I have 5 times x, which is 5x, and 5 times negative 1. So if I change this from plus a negative, that might be better. So 5 times negative 1 would be plus negative 5. If you just want to keep it as minus 5, that's okay too. And now I'm going to combine my like terms. All right, so y equals, well, what's 7 plus negative 5? Well, that's 2. I'm going to write this as 5x plus 2. Now, is this the same as this? Even though the 5x comes first, the 2 comes second, are they the same? Yes, they are. So are the following equations equivalent? Yes, they are. Okay. I wrote this 5x first on purpose, just so that way you can say, it doesn't matter if I take 2 plus 5x or 5x plus 2, I'll get the same answer. So we have the same equation representing the same line, but the two equations originally look different. There you go. Good luck.